Now in this session, we are going to understand about the data types that are supported by Numpy package. In Numpy, there is a provision to support various data types, starting with the Boolean. What is a Boolean data type? For an example, I want to declare a variable with the value true. The moment you declare this way, the moment you assign a true, the value of true to any variable, Numpy interprets this variable is of a type Boolean. Okay, if it is a Boolean data type, within the main memory, 1 byte of memory gets allocated. For this VAR, 1 byte will get allocated because the size of the Boolean data type is equal to 1 and only 1 byte as equal to as in C language. That is what the Boolean for you. Boolean can take either 0 or 1. 0 actually is false, 1 actually is equal to true. But understand carefully, if you simply want to store as 0 or 1, we don't require one entire byte, right? We require only one digit. One single flag of one digit is more than sufficient, right? But why do we require to use 8 bits? This is the question of interest. We should be able to understand why do we require to use 8 bits? For a Boolean variable simply, if it is a true, it is 0. Sorry, if it is true, it is 1. If it is false, it is equal to 0. But why should we still be able to use one byte, one complete byte? Why we still are provided with one complete byte? One simple reason behind this is memory cannot be organized as independent bits. A smallest measurement, storage measurement in the main memory is equal to 1 byte. Even if you do require to store only 1 digit or 2 digits, we require to procure a complete byte. Is the actual reason behind getting one complete byte from the compiler or interpreter. Because bit cannot be organized independently in the main memory. One bit should be a part of the byte. The smallest measurement, smallest chunk of the memory that can ever be clustered and utilized only is equal to 1 byte. If you ask for simply, and I just put in a very simple word, you went to the memory and ask, Mr. Memory, give me some amount of memory. Immediately it will ask you, how much you want? Give me as little as possible. So memory obviously is going to give you 1 byte because it cannot divide this byte into multiple bits. It will not be able to cluster or divide this byte into any more further pieces. The smallest piece of the memory is equal to 1 byte, which is equal to 8 bits. This is a very reason why, although it just takes only 1 bit, you will get the complete 8 bits. The second thing is int I. Int I means platform integer. What is a platform integer? The normal integers that are used in any programming language. Generally, the normal integer size is int 32 or int 64. What is int 32? Integer size is equal to 4 bytes. 4 bytes of integer. What is int 64? Integer size is equal to 8 bytes. In the older compilers, actually integer byte actually is starting from 2 bytes. Before 2000, in the older compilers, size of the integer just is equal to 3 bytes. Just was equal to 2 bytes. Now, right after 2000, in the advanced compilers, integer size would either be equal to 32 bits or 64 bits. It's a normal platform integer that are being used by any programming language. What is a platform integer? Int 8. Sometimes, what may happen is, if you actually are requesting for one integer, depending on the compiler or the interpreter, you will either be provided with 4 bytes or with 8 bytes. But the thing is, whenever I do not want to store much amount of value in the integer, procuring 4 bytes or 8 bytes actually is a memory wastage. I know what the value that I am going to store in this integer. The value is not going to exceed more than 100. I know exact value that can get stored in the integer that I am going to create. That integer value can never go beyond the threshold range 100. If you're not going to store any larger value, if the value is just getting confined from 0 to 127, there is no point in procuring 4 bytes or 8 bytes, for which I can declare something called int 8. If I say int 8, what can be given? You will be provided with one and only 1 byte, not more than 1 byte. So although it is just 1 byte, you will be able to store an integer which is ranging from -128 to 127. Because in an integer, you will have 8 bits. This is 8 bits. In these 8 bits, first digit will be sign. Remaining 7 digits, you will be able to store your value. Since the first digit is equal to sign, 0 is positive, 1 is negative. Remaining 7 digits, in the remaining 7 digits, you will be able to store the value, that is 2 power 7. 2 power 7 minus 1, plus or minus 2 power 7 minus 1. Okay, so that is minus 128 to plus 127. This is the maximum range of an integer. Int 16. If you ask for int 16, obviously compiler is going to provide you with 2 bytes of memory, in which the maximum representable size will be 2 power 15 minus 1. Here there will be 2 bytes. Here 2 bytes will be provided, in which the most significant bytes first bit will be for sign, and remaining total 31 bits actually are available for storing the value. The maximum value that can be stored in 31 bits is equal to 2 power 31 minus 1, plus or minus 2 power 31 minus 1, this one. Similarly, int 64, you will be provided with 4 bytes. The maximum representable range is minus 2 power 63 minus 1, plus or minus. uint 8. What is uint 8? Sometimes we may have to store the values that actually are unsigned. We don't want to use any sign. Signs are immaterial. Is it positive or negative? That is irrelevant to the context. At that time, we may ask for uint. What is uint? uint 8 meaning you will be provided with 1 byte, in which each and every digit will be only for storing the value. Not even the most significant digit is going to be allotted or allocated for the sign. In uint, you will be provided with 1 complete byte, in which each and every bit only is going to store the value. That means the maximum range will be equal to 2 power 8 minus 1, plus or minus. I hope you got the point. Second thing is uint 16, total unsigned integer. This is 0 to 255, meaning if you do have 8 bits, the maximum representable value is 2 power 8 minus 1, right? Because the value will start from 0, end with 255. Because 2 power 8 is equal to 256. So what is total 256 values can be represented. The maximum value will be 255. So if you do have 8 bits in 1 byte, the maximum representable value is 2 power 8 minus 1. Okay, and there is no negative signature here. Similarly, uint 16, 2 power 16 minus 1, that is 32,700 and 2 power 16 meaning, bigger pardon, yeah, it is 2 power 16 minus 1, 2 power 16 minus 1, 64k, okay, 64,000 exact is, yeah, 65,535, 64k. What is 64k? 64 into 1024. 64 into 1024 is equal to 65,536. Since we are starting from 0, the maximum representable value will be equal to 65,535. Okay, and uint 64, unsigned integer, 2 power 64 minus 1. Similarly, float 16. When you say float 16, half precision float. What is float? You know the difference between integer and floating. In floating point value, we have a binary point. In integer value, we do not have a binary point. So here, float 16 meaning 2 bytes will be provided to store your float value. In floats 32, 4 bytes will be provided to store your float value. Float 64 are float. Simply is a double precision. Sign bit 11 bits are exponent, 52 bits are mantissa. There is somehow we are going to divide this entire floating value into mantissa and exponents in the physical session. In the offline session, I am going to explain how this mantissa and exponent is going to work, but that's not relevant here. In float 64, what will happen? There will be 8 bytes provided. If you simply declare float, what would be the size that you're going to get? The total size that you're going to get is 8 bytes to store your value, in which there is some part called mantissa, there is some other part called exponent. What is this exponent mantissa? I am going to talk to you in our offline classes. Okay, And there also it's our complex values can also be represented. The complex 64, complex 128, complex 256. The complex values, the data type will be complex here. The complex values will be ranging from 8 bytes and 16 bytes and 32 bytes. Since the complex values actually are of in huge sizes, we may require to have some additional bytes. Complex values will be starting from anywhere in between 8 bytes to 32 bytes. The smallest complex possible memory location, memory size will be equal to 8 bytes. The maximum possible complex data type memory location will be equal to 16 bytes. We already discussed about the Boolean. For Boolean, we only require 8 bits, in which we'll either be able to store a true or a false, 0 or 1, 1 or 0 otherwise. Thank you.